Good afternoon, everybody. Is this volume okay? I think so. Okay, welcome to the talk about making Drupal fly. The fastest Drupal ever is now here. At DrupalCon Los Angeles, Fabian Franz and I did a talk about how the fastest Drupal ever was near. Now it is here. This is the same talk as I did together with Fabian at DrupalCon Barcelona. Any of you who were there may want to go to the different session because you've already seen this, unless you want to hear it again. As you can tell, I'm standing here alone. Fabian is not here, but I brought him in person, or in some shape or form, because some parts he was doing, and I will attempt to deliver them as well as I can, but Fabian is Fabian, and I can't match him, so Fabian is here as well. Fabian works for Tag1, I work for Acquia, I work on Drupal core full-time, basically, and have been for the last few years, and Fabian was given a grant by Acquia to help work on making Drupal 8 faster. So this is why we were presenting together the improvements that were made. But given that introduction, let's get started. So let's start with a quote. The quote is, "I have installed Drupal, however it's running very, very slowly. Hitting the front page or clicking on a link such as administer can result in delays of 15 to 30 seconds. Caching is enabled. There's almost nothing in my installation, very few users and very little content." You may suspect this is about Drupal 8, but actually this was about Drupal 4.7. So people have been complaining about Drupal being slow since forever. Same for Drupal 5. Why is my Drupal size so slow? Drupal 6, a wonderfully eloquent quote here. "Navigating between admin pages is slower than an arthritic snail," which is a beautiful image. So Drupal 6 was also slow. Drupal 7 is unacceptably slow. And so really, Drupal always is considered a snail. The question then is, Drupal 8, is it also going to be an arthritic snail, or worse, or better? Let's find out. So this is Fabian's part, really. He said keep calling cache, because that's what you would expect, right? And in fact, caching, the page cached, as we all know, probably in Drupal 7, who's used page cache in Drupal 7 before, show of hands. Okay, very few people. That is very bizarre. Maybe most of you are not actually listening, I'm not sure. Anyway, page cache. Actually, we had that since Drupal 3 in 2001. So that's how long back it goes. It looked like that. Dries committed this, Dries wrote this even, I believe. It's using lots of globals. That was the fashion of the day, I would guess. But we've had page cache in some shape or form since back then, since 14 years essentially. Here's a chart comparing Drupal 4.7, Drupal 4.7.5 performance. So from a long time ago, you can see that there's quite a stark difference between them. This was from a blog post by Dries many years ago, just before the release of Drupal 5. Generating a page in Drupal 5 is 3% slower, he wrote, but serving a cache page is actually 73% faster and even close to 3 times faster when the aggressive database cache is used. So as you can see, even back then, people were complaining that things actually were getting slower, Drupal's getting slower, was more complex, and so on. But really, the more common cases were being optimized. It really is a matter of what you look at. You need to look at the right things. And also remember, Drupal 4.7 looked like that, so far simpler. So surely Drupal 4.7 serving some basic content is going to be much faster than 7 or 8. But overall, what we see here is a certain trend. People are complaining about the next version or the current version of Drupal being slow. So, talking about Drupal 8, Fabian, my fellow presenter here, made a comment at DrupalCon Barcelona, and he made the claim, Drupal 8 is faster than any Drupal before it. So, the fastest Drupal ever, are you serious? You're kidding, right? But I thought Drupal 8 was slow, because that's what everyone has been telling me, what everyone has been writing about. So surely it must be true. And Drupal 8 shipping with page cache doesn't really count, because Drupal 7 and actually Drupal 3 already shipped with page cache. So page cache being enabled by default in Drupal 8 also doesn't really count. Except it does. I will show him. This is kind of awkward because he was sitting and not me. But so we'll hear more about that later. So let's take a closer look at a very short demo to show you what a difference Drupal 8 can make. So here I've got a screencast video that for some reason is not at the beginning. And I'm looking at Big Pipe here. And so we've got a relatively simple page with in the top left corner a personalized, slow, and cacheable block. Further on, we have a personalized block that is also slow, but is uncacheable because it's real time, if you will. And then we have something else that is also personalized, but is fast, and is also uncacheable. So looking at the traditional page rendering model versus Big Pipe with cold caches, Big Pipe is very fast, and the traditional model is taking quite some time. And so what we were seeing here is was those two uncacheable blocks, or the two slow blocks, I should say, each taking 3 seconds. And so in the traditional rendering model, that means that we have to wait for 6 seconds until we see something. For Big Pipe, that's no longer the case, because Big Pipe can do things in parallel, essentially. But note that it was the same total time. With warm caches, now that we're doing a second page load, Big Pipe is equally fast as before. And the traditional one is now faster because one of the 3-second blocks is already cached. And note again that we have the same total time, because Big Pipe, even when you're using that, you have to use, or you have to do the same work, you have to do the same rendering. The difference is that with Big Pipe we can deliver things much sooner, and so everything feels much faster because the majority of things that you are actually loading that page for is already there. And I can't seem to get out of focus here. Interesting. So, if that was kind of confusing, the Big Pipe demo, so let's take a little bit of a slower look at it. And this part I'm not going to get perfect because Fabian did this one and it's pretty fast and pretty detailed, so bear with me. We're looking at a relatively complex page, so to speak. On the top left corner we have that high Fabian block that is personalized. Note that the first time to deliver was, or still is, 2.4 seconds, which is very slow. We're still using Drupal 7 style rendering right now. So we have that high Fabian block that is personalized, but imagine that that is actually something that is much more expensive. Imagine that it's, I don't know, showing this social graph or whatever for the current user. It can be something complex, it's just meant to represent that it's something personalized. Then in the comments, for some reason, we are showing the current time, the current Unix timestamp with every page load. Again, just to convey that there is some real-time stuff going on here. Now, Fabian is changing the placeholder strategy because you see at the top, select the placeholder strategy none. And now he's going to reload it, and things are going to be a bit different already. So now we have the placeholder strategy single flush, and it mimics essentially the same rendering as what Drupal 7 did. But note that we have two numbers now, the time to deliver the page and the time that it took to flush, to render, to send the placeholders. The placeholders are dynamic, it's a high Fabian and the timestamp. That was just because it was so slow because we have just essentially rebuilt the Drupal 8 container. Now we can see that it's only 30 milliseconds, 30, 26, something like that. But we're still using the single flush placeholder strategy, so it looks exactly the same. It's still rather slow. It needs to render everything before we can start sending content. So as you can see, 26 milliseconds approximately, and 2 seconds to render those placeholders. So those are very expensive and very slow. I have no idea why he's scrolling down here, except maybe to show that there's lots and lots of comments to render, and probably that's why it's taking 2 seconds. And Fabian is now going and changing the settings again. And the placeholder strategy is going to change from single flush to small pipe. And small pipe is basically Big Pipe without JavaScript requirements. And essentially, a better name for it, because it's no longer called that in the module anymore either. It's essentially aggressive flushing. So you flush until you encounter one placeholder, then you send everything until the next placeholder, you render that, and then send that part, and so on and so on. And so that already makes everything look much, much faster. You can see that just the high Fabian block is the thing that is taking some time. The comments are showing up right away because those are first in the DOM order. But overall, still it's taking 2 seconds. I think it's taking 2 seconds because somewhere on the page there is something else that we're not seeing here that is making the overall time take 2 seconds, because as you can see, the high Fabian block is not taking 2 seconds. But right now we are confined to the order that things appear in the DOM, and that is not ideal because the comments are far less important than that Hi Fabian block. We care much more about that personalized block. So we actually want to have that one show up first. But with the single flush, or this strategy, we cannot possibly do that because it depends on the DOM order. So Fabian is now changing it to PinkPipe. And now we can render things in whichever order we want. You can even provide a UI that says, I first want to have this personalized, super dynamic, uncacheable thing show up, then that one, and so on. So as you can see here, if you look where the cursor is now waving, if he refreshes again, or maybe next time we'll see it better, you'll see that the pager for the comments, because there's many comments, the pager is there. Let me try to see that again, show it again. Did you see it? So there was the pager there. And so what you can see here is that the comments are being delivered later now. And it's no longer in the DOM order, it's just appearing whenever BigPipe receives it. There it was again. So with BigPipe, we can actually deliver something that is perfectly useful within 30 milliseconds, just like you saw in the recorded screencast earlier. And it just depends on which placeholder strategy you use. And so Drupal 8 is perfectly capable of delivering complex pages very, very fast with just a very expensive bits delivered somewhat later. So I don't think any of you were able to do this kind of thing with Drupal 7 before. So that's a pretty cool new capability, and I will show more about that in a minute. If I can minimize this. So, what you just saw is part of the mission to make the whole web fast, because what you just saw doesn't actually require any coding whatsoever. The mission is, or the challenge was, and this is kind of strange again because this was Fabian talking, not me. So I created a challenge, if you will. Maybe some of you know performance plans. Every year there is an advent calendar, like you see, for example, for CSS and so on as well. One of them is for performance, web performance. So 2 years ago I wrote about how the likes of Facebook and Google and so on have lots and lots of engineering power. They have lots of people that can work on making their sites fast. But what about the more normal people, the smaller businesses, even the bigger businesses, but that just don't have hundreds and hundreds of engineers? I think that it should be possible for the entire web to be fast, and definitely also for smaller business owners, even if they have a e-commerce shop and whatnot. And the idea is that everyone can benefit from faster websites and not just Facebook and Google, who then get to dominate everything else, which is kind of what you were seeing with the Google AMP thing earlier. So the goal is quite ambitious, but let's first see what fast actually means. It means great user experience. Pages must be loading fast for a single user, must also be loading fast if you have many simultaneous users. And really fast means that the time to first byte, so the time to start receiving a HTML response, plus the loading of the assets in the HTML response, plus the rendering in the browser, not on the server, so the browser showing something, plus the execution time of JavaScript, that together is minimal, because those things, and especially the first three, those mean, if they are low, that means that you are seeing something that you were looking for, that you were waiting for, very fast, instead of having to wait seconds until every single tiny, stupid, potentially not very important bit is actually showing up. So the question is, how do we achieve that? Well, simple. You can use static HTML pages, no CSS, no JavaScript, no images, and just text and links. But yeah, seriously, no, of course not. But there is some truth to that. Because performance optimization means optimizing doing for as little work as possible total, as few resources as possible. And together, that means that for the critical path, so the critical path means from the time you request a page to actually seeing something that is useful, which is a thing that this is all about. We have to ask the question, can we avoid doing the work at all for a particular part of the page? As in, omit it, is it really that important? Or at least avoid doing it during the critical path, which is the very minimal thing you need to do before you can show a response to the end user. And if we cannot avoid it, can we then at least cache it permanently? But sometimes some things just change too often, so we cannot cache it permanently. So can we then at least cache it temporarily? Or if even that fails, can we then at least defer, postpone executing it to after the main content? And that is exactly where big pipe comes in. So the adage that Fabian has come up with is avoid cache defer. The first step when doing something is asking yourself, is this really necessary? Because many Drupal sites contain lots of things that are really necessary. All those JavaScript trackers and silly blocks, many of them are simply unnecessary. So try to avoid things because they do all add up and make things slower. If you can't avoid, then cache, and if you can't cache, then defer. And deferring in Drupal 7 is very painful. In Drupal 8, it will be very easy. So caching has problems, because we haven't talked about that yet. I'm just mentioning here caching as a solution, but the problem is that the content should always be as current as possible, have a high cache ratio, because otherwise it's not very useful, and have low cache invalidation complexity. And you may all know the saying, there's only two hard problems in computer science, naming things and cache invalidation. Well, cache invalidation can indeed be very complex, and so it's important to keep it as simple as possible. But the problem is we cannot have all three here. We have to choose two. And let's look at a few examples to make that more clear. So low complexity cache invalidation. A good example for that is time-based invalidation. Time-based invalidation just means that you can, for example, cache pages unconditionally without ever considering to invalidate them for a year. The problem is that then the content is not actually current. It could be 11 months and 30 days old. But the cache hit ratio is great. As soon as there is one hit, everything after will be 100% cache hits. The other approach is to never cache pages. The content will always be current, but the cache hit ratio will be 0%. And unfortunately, that is basically how Drupal 7 sites operate. We don't have the necessary metadata, the necessary APIs, the necessary infrastructure to be able to cache pages correctly and invalidate them correctly. And so what we do is we just don't cache at all, and we just render every single thing over and over again. Even if it's the exact same HTML response, we render it tens of thousands, hundreds of thousands of times, which is just silly if you really think about it. Imagine that operating systems would work that way, and CPUs, that would be so very slow. So another thing that we could do is caching pages for, say, 6 hours, and then we have struck some kind of balance in between. We cache them for up to 6 hours, so the content is always relatively current, and the cache ratio is acceptable. But this obviously is not a generic solution. It doesn't work for everything. If you have a news site and you have breaking news, and then you click the link, and then you have to wait for 6 hours for it to show up, that would be quite silly. So time-based invalidation really is not a solution. The other approach that we can take that is of low complexity is the clear all approach. Whenever anything changes, clear everything. And that is Drupal 7 doing its page cache thing. So Drupal 7's page cache, as soon as any comment is posted, any node is updated, whatever it is, the entire page cache is invalidated. And not just for nodes, for every single thing. So sure, page cache in Drupal 7 works, and sure, it makes things faster, as long as nobody's doing anything on the site. So Drupal 7's page cache, yes, it works, but only for very, very, very simple sites this is actually useful. So we talked about the low complexity ones, so let's look at the high complexity ones. And in Drupal 7 Contrib, you can have, there are some solutions, and the idea then, of course, is to clear only what has changed, to invalidate only the things that have actually changed. And in Drupal 7 we have the expire and varnish modules. And what they do is, or what they have to do is, they need to purge every single URL that contains content from anything and then track that. So for example, if node 5 is modified, this module needs to figure out every single URL where that content appears on, or node 5 appears on, and then invalidate it. But how can you possibly know that? How can you possibly know every single URL it appears on? It is very easy to make a mistake and not invalidate enough, and then you have still content showing up, or make the opposite mistake and clear too much, which means that you have a lower cache hit ratio. And so that's a very difficult problem to solve, and it's not really solvable with the APIs and infrastructure that Drupal 7 has. And that's why Drupal 7 went a simple approach, which is anything changes, let's clear everything, which works. It's resulting in correct behavior. But even though Drupal 7 only does that for nodes and comments and those kinds of things, but if you change any setting or so, it will stay wrong until you manually go clear the page cache. So it's quite clear what the problem is. We don't have the necessary infrastructure. And even this has a high invalidation cost because it is very painful to set up. You have to basically set up a lot of rules to map certain node types to certain URL sets, and then pray that it's the full set. That's not really workable. So Drupal 8 also chose high complexity, but a different approach, as we'll see. So content is invalidated instantaneously, which is what we want, and it's cached permanently, which is also what we want. And we do that, or we achieve that using cache tags, and we'll talk more about that later. So caching has even more problems than what we already talked to, because content should also be varied correctly. It should be varied by the current user, by the current user's group, maybe some special permission. And you could even do custom crazy things like Phase of the Moon if you have a website with a particular need, like for example a shop, online shop, and maybe there's a special deal of the week kind of thing. Maybe you need to vary by country, maybe you need to vary by combination of country and language. I don't know, there's lots of special cases. You need to make sure that cache entries actually vary correctly, because otherwise, if they don't, that means that content intended for you will actually show up for you, and that's information disclosure, and depending on the type of information, that could lead to very nasty consequences. So it needs to vary correctly, but still have a high cache hit ratio, and ideally also have low complexity, as in the logic to ensure that the caches are indeed varied sufficiently. But again, the problem is we need to choose two. We cannot have all three. And so yes, again, Drupal 8 shows high complexity. Everything must declare what it varies by. So every render array declares what things it varies by. But this has a great consequence, which is that we can actually finally do caching for authenticated users as well in a secure manner. And the solution there, the concept that we have there, is cache contexts plus placeholders, and we'll talk more about that later. So wait a moment. What about the KISS principle, the keep it simple, stupid principle? This all sounds relatively complex, right? The counter question is, who of you use a database? Show of hands. Is there anybody using no database and just static sites, maybe? It's possible, but it doesn't suit every use case, or you can't do every use case with it. And remember that databases are actually beasts of complexity. Does any of you know exactly how MySQL, for example, stores a certain row somewhere on disk? I don't think so. Does anybody of you know how it retrieves that, how it optimizes its query plans, how it converts SQL into query plans, how it uses SSDs versus hard disks, how it uses memory, and so on? There's a lot of complexity going on, but you don't see any of that. You just give it hints, indexes and so on, SQL and so on, and the database system, the software, does its magic. And Drupal 8 is similar in that regard. It makes it as simple as possible for you as the end user. And this is a huge opportunity because for the first time you will no longer have to write custom code all over and over again, the same kind of patterns applied slightly differently to different projects and so on. Drupal 8 takes care of those things. You just need to provide the necessary metadata. So if you give Drupal that metadata, then it can be smarter about its decisions. And so Drupal 8 formalizes those things in a language. I think language is maybe the wrong term. I think a set of concepts is a better one. But Fabian wanted to make the comparison to SQL, which is a language. This is kind of similar in that regard. And if you use the language, the concepts correctly, then your site will be fast. So no more need for manual, painful optimizations. Note that Drupal 7 can actually use the same concepts, the same language, once it is finalized in Drupal 8. So Fabian maintains the render cache module for Drupal 7, which brings render caching to most entity types. And he also maintains a service container module, which is basically a backboard of Drupal 8's service container. And this means that you can actually, if you are working on Drupal 7 projects right now, and you either know that they will migrate to Drupal 8 at some point in the future, or you want to learn more about the principles of Drupal 8 and how it works, you can actually use this and use the exact same code in Drupal 7 as you do in Drupal 8. If you write services, and you just use those services in your procedural Drupal 7 code, you can perfectly well use the same code in 7 and 8. So if you're interested in that, definitely check that out. So the question then is, we've talked about these concepts, about this information. How do we present? How do we give it that information? And that's what I will show now. So this was the Fabian part. Moving on to the thought process that goes behind this. So this is the thought process that most AAA developers will either have to or already naturally adopt. Many of us will already do this just because we're conscious of performance. So the thought process of how making Drupal fast. Dependencies. Dependencies is everything that is important in caching things, because without dependencies we cannot cache correctly. So for example, Drupal 7 didn't track any dependencies. How many of you have used Drupal add CSS and Drupal add JS? Have used, I said. How many of you still actively use it in the last few weeks or so, say? Oh, a few people, great. Because the problem with these functions is that they're globals. Or rather, they modify some global state somewhere. So if you are rendering, say, a block, and that block calls, or the logic to render that block calls Drupal add CSS, Drupal add JS, that means that somewhere in global state, somewhere far off, we know which assets should be loaded for the current page, but we cannot possibly know that it's associated with the render array for the block, or whatever it is. So how can we make that connection? How can we know that these assets belong to this piece of markup? We simply can't. So the end result is that if you use Drupal add CSS and JS, and you are using some level of caching, that the assets will be missing the next time you retrieve the markup from the cache. So it's important that we know the associated metadata. And so, because it was global state, this was impossible to cache. In theory, people still did it and accepted that some things were broken. The solution is very simple and actually already exists in Drupal 7. Use pound attached to attach asset libraries. You can already do this in Drupal 7, so if you don't do that yet, do so please. That will make it easy and make it easier to transition to Drupal 8. There's something I should have said here. It's gone. So use attached, that will make it easier to transition to Drupal 8 in any case. And in Drupal 8 you don't have the option to use Drupal add CSS and JS anymore. It's just pound attached that you can use. So there is no potential for polluting global state and having caching be broken. It just works because it doesn't allow you to do the wrong thing anymore. Another example of Drupal 7 not tracking any dependencies was the URL function. I think everybody has used the URL function. Show of hands who has, yeah? Did you know that you were messing very deeply with global state? Because this function depends on the front page configuration, HTTPS configuration, including URL configuration, the current site and multi-site, and so on, and so on, and so on. So really, this was impossible to cache, or at least to invalidate. But many of us did it anyway, because the URL function at its surface seems very innocent. It seems like, hey, I pass in this bit of these arguments, these parameters, and I get back some outputs. And the arguments depend solely on the input I provided, but actually it depends on all of these global state things. And so dependencies are lost, and that means that, for example, if you render something and it's, for example, the current request is HTTPS, that's cached. The generated URL has HTTPS, is cached. But then somebody accesses the site over HTTP, and they do get the HTTPS URL as well, and vice versa. So there's lots and lots of problems there, but we ignored them mostly. And we were able to ignore them mostly because we were simply not caching anything very often. As soon as we encountered these problems, well, okay, page cache doesn't work apparently, we disable it. And that has some consequences, of course. So, now we get to the very interesting bit. Correct invalidation in Drupal 8. The language of Fabian was referring to, the concepts are these three: cache tags, contexts, and max age. Tags are for data dependencies. They describe what data some render array or anything else that is computed that maybe cache depends on. So if you're computing some very complex value and it looks at 50 nodes and gets some field or whatnot, then it would associate the cache tags for all those 50 nodes. If you're rendering, for example, the title of a node, you would associate the cache tag for that one node, and that allows us to track what a specific cache thing depends on. And that allows us to invalidate it correctly so that we don't have to go and guess every URL that appears on, or just clear out an entire cache, because we can specify, we can find which specific cache entries should be invalidated. That's what cache tags are for. Cache contexts are for context dependencies, request context dependencies. So for example, the browser specifies the current preferred language. The current URL is also request context, the session, the cookies that are received, those kinds of things. If the outputs or the computations vary by one of those aspects, then you need to specify the matching cache contexts. And finally, cache max age for time dependencies. Some things, this is not very common in Drupal, but sometimes you have things that are naturally only valid for a very short period of time. For example, the current temperature. In theory, it changes every millisecond, every microsecond, but nobody is actually going to refresh or is going to care about microsecond changes in temperature. So what you can do there is, for example, cache that for up to a minute, and that's still giving a very real-time bit of information without having to cache it permanently, so that it does update every minute or so, or whatever you specify. So these three concepts, together with bubbling, this is where Laurie is going to do his show, I think. So cacheability metadata bubbles up, literally, from the fragments of a page. So you know a page consists of regions, a region contains blocks, blocks themselves contain content. Well, the content contains those bubbles here. The bubbles bubble up from the content of the block, to the region. The different blocks as cache tags and cache contexts and max age are merged together at the region level then. And the different regions bubble up and merge together at the page level, and so on, up until we are at the response level. And so the fact that we have those kinds of dependency metadata plus the bubbling means that for a given response where every bit of HTML has been fully assembled, fully combined, and the cacheability metadata associated with those is also fully combined, that means that we can actually know for a fact the entire comprehensive exhaustive sets of dependencies for that response, which means that we can vary it correctly thanks to the cache contexts, invalidate it correctly thanks to cache tags, and not cache it for too long thanks to the max age. And that's why those three concepts plus bubbling are so important. So in practice, try to make this thought process a habit. First of all, realize that you are rendering something, or maybe computing something, but this is specifically about rendering for now. So it's very easy to just return a string, return a render array, whatever, and not even think about it. But it's important that you specify the right cacheability metadata. If it's a static string, sure, that's fine. But if it's translated, or if it's depending on the current user, or maybe it is only shown to users with a certain permission, then it's important that you think about those things. And so the first step is even realizing that you need to think about cacheability metadata. The second step is, if it's something that is expensive to render, if you know that it's expensive to render and it's worth caching in its own, so a fragment of the HTML that you want to cache, then you need to specify the cache keys. And this is something that already existed in 7, actually. So it's just a list of things that are concatenated together to form a cache ID to find it later. Together with the cache ID, we also have cache contexts, which capture the variations. So the cache ID consists of the keys plus the contexts. And a context, as you can see here, is for capturing, describing which aspects that something varies by. So, as I mentioned, perhaps something is translated and needs to vary by interface language. Perhaps it depends on the current URL, then it needs to indicate that, and so on. So examples of that are at the bottom there. As for example, varying by user permissions, varying by the URL, and so on. Well, all of those things should probably ring a bell already. That is extremely similar. It's actually identical in concept to the HTTP vary header. Exactly like that. Next, is there something that causes the representation that I'm rendering to become outdated? Is there something that it depends on that if that changes, I should change as well? If the answer to that is yes, then you need cache tags. And examples there are, for example, this render array depends on node 5, user 3, and taxonomy term 23. Those then indicate those dependencies. And last, if the representation of the thing I'm rendering becomes outdated after a certain period of time without anything else specifically changing, like for example temperature, then max age is something you should think of. And by default, the max age is permanent, meaning there is no maximum age, it can be cached permanently. but you can specify any max age in number of seconds. And max age 0 means that it's not cacheable. And this also should ring a bell because it's exactly like HTTP's cache control header, and specifically is max age field. It's exactly like that. So we are really just importing certain HTTP concepts into Drupal, doing it at a more granular level, because Drupal is basically a huge string concatenation machine that emits HTML, and we need to know for each bit of HTML what its cacheability is so that we can send the right headers, the right HTTP headers. And so it is very, very similar to that. We just need to think about it at many more steps along the way. So this may seem kind of painful, specifying the cache tags manually, like, well, how do I figure out what those strings are and so on? Well, there's good news. All relevant objects, ones that are kind of things you could depend on while rendering or making computations, those all implement the cacheable dependency interface. They are cacheable dependencies that can be cached. And so they return, or they give you the context, the tags, and the max age for whatever thing it is, whatever object it is. It's implemented by just about everything you would use. So configuration, any entities, config and content entities, access results even, block plugins, context plugins, condition plugins, and many, many more things. So everything in Drupal 8 core already provides you with the necessary cacheability metadata. It's just a matter of, hey, I'm using this thing, let's depend on it. And to make that depend on it part easier, there's a helper method, renderer at cacheable dependency, where you pass in a render array, the one that you're building, and the dependency. And so a concrete example would be like that. You retrieve the site name. So if your site is, for example, DrupalCon Leuven 2015, that's what you're retrieving. But the fact that somebody could change it to say unicorns and llamas are awesome, for example, when that changes, we need to know about that, and we need to make sure that the cache tag is there, and this ensures that that happens. So, to conclude this part, if Drupal pages are like ships, because Drupal rendering a page is roughly like building a ship, then Drupal 8 looks like this. It's assembled from components. You can see all the different cabins in there. There's clear dependencies. It's clear where the walls are, where the support structure is, and so on. So this kind of makes sense, right? But then this is kind of like Drupal 7. It's still a boat, but it's impossible to decipher the structure and where every bit is coming from, because there is so much global state going on. We don't track dependencies correctly. So Drupal 8 does much better in that regard. So the remaining problem we faced after all that was that even with all those dependencies, the cacheability was not good, and things were slower as they could be. Why? Well, just having a cacheability metadata is not very helpful if it still takes seconds to render a page. But reality is that pages are both containing static parts and dynamic parts. So the static content would be something like a blog post or an article. But just about every site and just about every Drupal page and site contains dynamic parts, blocks that are very dynamic, forms that are dynamic, and so on. And those things actually are not cacheable, and therefore they slow the entire page down. So what if we can change that? Because even just caching this, even if we would cache this, let's say we do, let's say we have lots and lots of server resources, let's say we have infinite servers, as many as we would like, then even just a site with 100,000 pages and 100 users, or say 10,000 pages and 1,000 users, that means 10 million combinations if there's any of those blocks are per user. 10 million combinations. What do you think the cache ratio will look like? It will be absolutely terrible. It will be close to useless. So that's not really a helpful way of looking at it. We cannot cache just everything. So again, what we could do is make the pages less dynamic. Problem solved, right? Well, not really, because that would mean you have static pages again. That doesn't work either. Static HTML is not very helpful. So Drupal 8 is a solution for this problem as well, and it's already in core. Placeholders and AUTO-PLACEHOLDERING. I briefly referred to that in the initial screencast, but we'll get more into that now. So, placeholders, what that effectively means is that we won't be dealing with this anymore, where we have a part that is static and then dynamic parts, and dynamic parts make the overall page very slow. But instead, because Drupal 8 has now that cacheability metadata, it knows, in this case, the variations of something. So the shopping cart is to be cached per user. because I don't need to see your shopping cart or your shopping cart, I want my shopping cart, right? And so the other blocks here, for example, are per permissions, so they depend on having a certain permission, and the other one also depends on the current URL. Those are perfectly fine cacheable. There's not too many different versions of those, but per user caching, that is kind of painful, because it means that the overall page would need to be cached per user, and that is just not workable. So Drupal 8, what it can do is it can placeholder automatically. So instead of rendering that shopping cart block, what we do is we render a placeholder instead. And then the end result is that it looks like this to Drupal. So an entire page in Drupal, while Drupal is rendering it, the Drupal render pipeline is rendering it, it looks like this. We have the placeholders for the head tag in the HTML, the CSS at the top, the JS at the top, and the JS at the bottom, because any of the placeholders, the placeholder 1, 2, and 3 there, those could themselves emit additional assets that need to be loaded. So we have to render those assets loading HTML bits as late as possible. But essentially, we have smaller parts, or the parts that are not changing too often are there, fully rendered, but everything else is just a placeholder. And that's the essence of how Drupal 8 rendering works, because it means that in attached we can now have no longer just assets, but also placeholders, and the placeholders use independent lazy builders. And that's a new term, so let's take a look at that. Lazy builders. What are those? How many of you have used pre-render callbacks in Drupal 7? Oh, a handful. This is very similar to pre-render callbacks, but it's much more strict. And because it is much more strict, it allows for much more interesting use cases, including late rendering, including deferred rendering. So let's take a quick look. I'm looking at a render array here, and for this subtree, the subtree below complex thing, we don't see any render array, really. We just see a lazy builder that is specified. Current lazy builder that receives a callback and arguments. This is kind of similar to pre-render callbacks, but note that there is only one callback, and there can be, not like pre-render, where there can be multiple. And so there is nothing else. And why not? Well, because as we will see in a second, a lazy builder is meant to encapsulate something that can be rendered later, but therefore it needs to be able to represent the entire subtree. So for example, if a certain block uses a lazy builder, then the entire block must be rendered through the lazy builder, because otherwise, imagine that already part of the block would be in here listed as well. How could we then possibly merge the thing that is already in there, plus whatever the lazy builder will return? There is no way. So lazy builder is very strict in that. It represents an entire subtree. It represents that that subtree can be built lazily, hence the name. It can be built later whenever we want to, when it is convenient and how we can make things as fast as possible. So a concrete example is a comment form. The comment form uses a lazy builder as well. So we have a callback there, which is a service name, method name, and then there is a bunch of parameters. So entity type that is the comment is on, the entity ID for the comment, of the entity that the comment is on, the name for the comment field, and then a certain comment setting. And I said it was more strict, and you can tell here already that what we're getting here is just integers and strings. And that's exactly because it enforces you to. Lazy builders can only receive scalar values, so ints, booleans, strings, and so on, floats, as well as null. So only things that are very easily serializable. So no objects, because those are expensive to unserialize, those are expensive to load, and so on. So we avoid all of that. That allows us to then cache the lazy builder. And as I already mentioned, when a lazy builder callback is specified, no children can exist. Precisely because otherwise we have no way of knowing how to merge the render array, the markup generated by the children that already exist, plus whatever the lazy builder returns. So a lazy builder in summary is very simple. It is very similar to pre-render callbacks. It builds a render array and returns it. A pre-render callback operates on an existing one. This one builds one from scratch, and that's why we can build it or run it as late as we want, because it's very simple to call. And the output must depend solely on the inputs, the arguments that you give. That's why it is independent, why we can run it whenever we want. And these two facts together allow us to render things in isolation. And rendering in isolation means that we can do things like BigPipe. It means that we can do things like ESI without having to write lots of crazy code figuring out which specific part of a render array of a specific page can be rendered via ESI. It's a lot of manual work in Drupal 7. In Drupal 8, it can be largely, if not completely, automated. So that was placeholdering. Placeholdering at a high level depends on lazy builders. But we also want to be able to do that automatically. We don't want to have to determine when a lazy builder should be called early or late, as in when a lazy builder is returning something that is too dynamic. If it is that we want to do it late, if it's not dynamic, then we want to do it early, because then we can cache it together with everything else. So auto placeholdering is where that comes in. You can configure this, and these are the defaults. So the conditions for automatically placeholdering are max age is 0. So if the max age is 0, then the thing will be rendered later dynamically because it's uncacheable. Context, if something varies by session, the current session or the current user, then that also means it's too dynamic. But if your site, if your infrastructure, for example, has only 10 different users total, then you could choose to omit the user there. Because for your use case, it may be totally fine to cache everything per user because you have few users. So you can tune this to match the needs of your site. And even tags, currently by default Drupal doesn't list any, but if you know that, for example, a certain node is updated so very frequently, or a certain setting is updated so frequently, then the cache tag for that you can specify in there. And that means then that whenever a render array contains, a fragment contains that cache tag, it will not be rendered immediately, it will be automatically placeholder to be rendered later. So when we encounter the user cache context there at the bottom, so we call the lazy builder, we get back the fact that it is varying by user. If we detect that the current user is a cache context, that means that the conditions we just saw, the condition is met. So we set create placeholder equals true at the bottom there. This is all it uses, and this is just an API that, like any other, you can use. So you can specify create placeholder true manually to enforce that something is placeholder if you know that something is super dynamic always. So you can force Drupal to do a certain thing, and you can also force it to do the opposite. If you set false, then it will never be placeholdered. So you have a lot of control there. But by default, it isn't set, and then auto placeholdering will apply if the placeholdering conditions are met. Then finally, we have that create placeholder equals true thing up there. During the render pipeline, then Drupal, instead of calling the lazy builder and rendering that content directly, what it instead will do is create a placeholder. So the Drupal render placeholder callback thing right there. This is the placeholder that will be sent to the, that is the thing that we are actually rendering. And what we're doing instead is then we're attaching a placeholder with this markup. Note that this matches exactly with this. And so as late as possible in the rendering stage with the single flush strategy that you may remember from the very beginning, together with the fact that you can choose to implement a different rendering strategy, as I will show you in a second. That means that this will be replaced with the final content as late as possible, and note that these two things match. So the original render array is stored here in attached for a certain placeholder. So what this effectively means is, hey, this thing, we're not yet rendering it, we're instead rendering this, just some placeholder markup that doesn't really matter. And then when the time is convenient, when the time is right, we choose to replace that placeholder by looking it up here and then executing, rendering that render array. And so essentially that is how you're able to do BigPipe, how you're able to do ESI and so on. And so, as I briefly mentioned, it's possible to define custom render strategies. And by default, we iterate over all placeholder strategies. The default is single flush, so that means that we're still blocked on everything, every placeholder being rendered. And only then, when the entire response is ready, then sending the response. But you can also implement a different one, like for example BigPipe. BigPipe will then just send placeholder markup, send the initial page, and then send in JavaScript that does replacements of those placeholders. So single flush doesn't really do anything. BigPipe returns custom markup. with a selector that JavaScript can find, it attaches a library, and then BigPipe renders it later, finds that markup via JavaScript in the final markup that was sent to the browser, and then replaces that with the markup that actually should be there, because it's then rendered later. Pitfalls and scenarios, I'll go over them very quickly because time is up, because the previous talk went over. Pitfalls and scenarios. So again, instilling this the thought process. If you're depending on configuration, don't forget to add its cache tag. So add cacheable dependency, build, and then config object. Depending on entity, don't forget to add its cache tags, depending on the entity. If you're depending on a field of an entity, then you need to add the entity's cache tags because a field is part of the entity. If you have uncacheable data, specify maxH0. If you're manually rendering a link, you have two options, using twig or use type link. There is no more Drupal function. You can do interesting scenarios like varying by cookie. This is something that used to be popular some time ago, but this is request context. A request receives a cookie. If there's a username cookie, then you can just specify, if your render array consumes that cookie, that it varies by a cookie with a named username. So you can easily specify anything from the request context, anything that you receive, anything that your output depends on. Another scenario is something that was also very popular some time ago, a device cookie. But you can even do that. You can even, if your site has a specific need, you can even force it, that cache context, so a certain variation to be applied always. So for that we have the concept of required cache context, and by default we have two. The interface language, because the T function is omnipresent, it's almost everywhere. It doesn't make sense to specify the interface language cache context all over. It doesn't also make sense to specify the theme cache context over and over again, because anything that is rendered, almost everything, has a template, and the template depends on the current theme and so on. So those things are taken care of for you. You don't have to specify those. But you can specify your own. So you could specify that everything needs to be cached per user. If you're building a site for a bank, for example, it could be interesting. They can just throw more servers at it. And in this case, for example, always vary by the device cookie. And that was it. Hope you learned something useful. And if you have questions, come talk to me later. Thank you.